That's what you're talking about. This section is absolute value inequalities. One thing you need to know about these is we have to get the absolute value by itself first. Be aware of the inequality sign and the number it's compared to, because that's going to determine our answer. So we'll look at just some basics. We have 4 different types that we could be dealing with. If you notice, we have the absolute value of x is greater than 5, the absolute value of x is less than 5, absolute value of x is greater than negative 5, and the absolute value of x is less than negative 5. So what's changed in each of these examples is the inequality and the number we're comparing it to. So it's greater than a positive, less than a positive, greater than a negative, less than a negative. And that's what we're going to do to determine how we set up our problem. Just a little reminder, a couple things. One, absolute value is a measure of distance. So what this says is our distance is greater than 5 from 0. So if you think about a number line, if here is 0 and here is 5, okay, and here is negative 5, we want our distance, our absolute value of x, to be greater than 5. Well, here are numbers that are going to be greater than 5, but then we also have these numbers, the numbers that are that way left of negative 5. So we actually have what is called a disjunction when we set this up. What you'll have is you'll have x to be less than negative 5, or x to be greater than positive 5. And of course we can write that in interval notation also, and we would say negative infinity comma negative 5 in parentheses union 5 comma infinity also in parentheses. So again, the way we determine that is anytime your absolute value is greater than a positive, that's what you'll do. This one's a little bit different. So what we'll do on this one is we'll say the distance is less than 5 from 0. So if this is 0, here's 5. Here's negative 5. So our distance is less than 5. So we're talking about the values that are closer to 5 than those two. And it could be a positive number we're talking about, or it could be a negative. Both of those will have a distance that is less than 5. So in this one, you actually end up with a conjunction. So you'll say negative 5 is less than, whoops, not equal to, less than x, which is less than positive 5. And then interval-wise, what you would say is negative 5, comma 5. All right, and then what we're going to do on the next one, it's pretty unique. We're looking for anytime you see an absolute value inequality and it's compared to a negative, you know it has to be one of your special cases. So kind of keep that in mind. If we're looking at this one, it says the absolute value of x has to be greater than negative 5. Well, the minimum value you could get from absolute value would be 0. So 0 or a positive number is always going to be greater than a negative. So therefore your answer is all real numbers, or interval-wise you can say negative infinity comma positive infinity. Now this one, again, we're looking for a distance to be less than a negative 5. Well, there's no way. Distance has to be positive. So there's no way a distance could be less than a negative. So therefore this answer would be no solution, which you could put something like that as your answer. So again, the way we determine how we which one we have is we look at two things. We look at our inequality, whether it's greater than or less than, and also whether it's compared to a positive number or compared to a negative. We'll look at a couple examples and see if we can apply this.